Okay, good afternoon. First time in Croatia, first time in Split. What a nice city, wow. In my hotel, they just gave me a bottle of wine just to say me welcome. I know I'm French, so bottle of wine, I was a bit worried. But you guys just produce amazing wine. It was perfect. I don't drink all the bottle for today, but tonight, I know I still have some plenty to go. So I will speak to you about API, how to design API, REST, gRPC, GraphQL. And it will be in Java. So among you, who is using Java programming language or Java developer? OK, not that many. Hopefully, after the talk, more will use Java. It's so easy to use, and you may very well be tempted to use it. So full disclosure, you will see some Java code, and I will do some live demo. So who knows could happen. OK, so I'm Cedrick Lunven. I'm a developer advocate for DataStax. DataStax is a company providing an enterprise solution for Apache Cassandra. That is during day. During night, I created an open source framework in Java, of course, 6 years ago, named FF4G. I mean, feature flags for Java. If you were there 2 talks ago, somebody talked about feature flags and performance improving you can get with them. And I'm also contributing to a framework named gHipster, which is what we call scaffolding. You provide your entities, your queries, and it will generate for you a full working application, backend in Java, frontend in Node.js. So during this presentation, come on. OK. I will explain how to build API on top of databases. And I need to introduce one of the databases I will use, which is Apache Cassandra. What a surprise. Because using Apache Cassandra, you get a lot of use cases. And based on the use cases, you won't use the same API technology, the same way to expose API. So get the methodology and demo and code review. OK, so what about Apache Cassandra? Well, Apache Cassandra is a distributed database. There is no point to have a single node, single server. It's all about distributed. On one node, you will have 1 terabyte of data and up to 3,000 transactions per second and per core. And if you need more capacity or more throughput, just add nodes. In this database, you have these nodes running in network. This network is called a data center or a ring. But you can have not only one ring, multiple rings like that. If you use multiple rings, we will speak about a cluster. And what can you do with such kind of database? Well, you can put nodes wherever you want. Cloud, on-premise, it's the same database instance. You can have the same data layer across multiple cloud and hybrid cloud. Some data on-premise, some data in the cloud. You don't have to duplicate the data for the new applications working in the cloud. It's all working for you, and you can read, write everywhere. And if you're doing some API on top of this kind of database, you have to be sure that you can implement for, I don't know, serverless, or because you're in the cloud and it's trendy, or on-premise with all the technology you are used to. Data is distributed. I told you that. So if I got my data, so data is distributed around the cluster. Each node got a chunk of the data. And if you get the data, you will know on which node to go and copy the data where it should be, where it should go. OK, maybe stay here. OK, now the data is also replicated. That means if the data came, it will be replicated on 2 nodes, And the best practice is actually to replicate on 3 nodes. So why I said you that? It's another use case of Apache Cassandra database is always on, always available. You can lose any of the nodes. It's not a big deal. And there is no master. So if you lose one node, you don't lose data because data is replicated. Last but not least, when you insert data into Cassandra, you can ask for the consistency you want. So you know that your data should be written in 3 nodes, but you can say, I want to be as fast as possible. And only when the first node responds, consistency level 1, I'm good. Use cases, IoT, high throughput. I need to write very, very fast. See, 1,000 transactions per CPU per core, 8 CPU per node, 20,000 transactions per core, 3 nodes. OK, you got it. And if you need more, add more. You can also say, oh, no, it's not an IoT use case. It's pretty important data. I need to have the latest data all the time. And for that, we will use a quorum. So at least 2 of the 3 will get the response. It's the majority. And last but not least, you can also do consistency level all, where all the nodes will respond. But never do that, because you won't be available. Any of the node that goes down, and your request won't answer anymore. So why I presented you that is just to get the use cases for Apache Cassandra. High throughput, high volume, high availability, and data distribution all over the world. That means that when you are creating a service, an API on top of this database, CRUD is not enough. You need to go beyond. So if I need to implement a database, an API on top of this database, well, we got a methodology to implement application on top of Cassandra, and API is part of that. And to illustrate all those, we have a reference application called Killer Video, killervideo.github.io, where you will see how to implement not only an API service, but a full working application with 4 technologies: Java, Node, Python, and C#. And I will use this use case, of course, to show you how we implemented the API. So, and the methodology is first, find your data model. Then we implemented the very same API using the 3 technology to know which is the best and to provide feedback. And I won't speak today about all the plumbers in the middle, never mind. So if I start with the data model at the bottom, what is a proper workflow to create the data model? And look, it will be quite the same for an API and for a database model. So first, I need the entities and relationship between the entities. Then I need queries, the way I need to access my data, which are the filters, paging, all that stuff. And with these 2, we can just go through the process. So if I go back to the Killer Video applications, there is some pages when we'll show comment for user on the video page and comment for user on the user page. So we have 2 queries. Let's get started with this use case. So I have my users. I have some video with some attributes and my relationship between the 2. This is my MCD, conceptual data model. This is my workflow. Give me all the comments for a user. Give me all the comments for your video, or CRUD. But CRUD is not fun. We'll see. So everybody can do CRUD. Any technology can do CRUD. So if I follow the methodology, I will create a table per query. This is like it is with Cassandra. There is no join. And I will just provide the attributes like that. Go to the physical data model, and finally get my SQL script, SQL. So even if there is a single comment entity, because it's used both in a user page and video page, I need to do 2 tables. OK, so this is our starting point for the API. we got the data model, we got the application workflow, your specification from your customer, and now you know which database you should use because maybe you have some high throughput, high frequency, high availability, and such requirements. So I will switch to a nice demo mode. So cross finger now. It's live. Okay. Okay, like I said. I said mirror display, but it's not. Okay. It's coming. Never mind. Okay, so this tool is called DataStax Studio, and it's just a web-based tool to working with Apache Cassandra. And so I will create the tables exactly the way we just defined together in the slide, just to get the tables ready. Okay, so now in the schema, I could see my SQL and get my killer videos and get my two tables here. So nothing fancy. Let's work with those databases. So I will now switch to Eclipse. I will. Okay, never mind. So I really need to switch to mirror display because otherwise I will have a hard time coding looking the screen. So display. Where else can I show extending? Where is it? Hopefully. Okay. Yes. Back to business. Okay, so I have a Maven applications with 3 modules. It's very small, but for the connecting to the Cassandra, I have some classes. I won't show you all the classes, but I will have some code to find all the commands for a user and some code to find all the commands for a video. Let's dig into find command for a user, and this is the API we will expose. So first thing I need to do is to generate some comments. So let's run as GUnit. Okay, so now let's see if I get my data here. So I've created some totally random comments, and he gave me a user ID. I will review here and see if we get the data. Yes, we get it. So we are all set up. I won't be annoying with my database anymore. Let's speak full about API. So first implementation is, of course, REST. REST existing since 1999 already. So I will start a REST API. This is the first of my 3 modules. So to expose a REST API is pretty easy. You will define some resources. You will try to reuse the HTTP keyword. So API, this is a good practice. Get v1, get my user ID, and get all the commands for my user ID. And you can see that you can do both documentation and implementation of your API like that. And there is some tweak and tips and tricks to do some paging, to do some sorting. So I will provide you a link in the end with all this code working for you. You just have to run on your laptop. So if I go to my browser and see if I got my REST API, hopefully it's there. So let's go to the user and try my API. Let's go. Here I got my user ID. And here I got my comment. So nothing very fancy. Just in my API, I want to do some paging. So if I provide a page says, now I got my 2, and I got some code to provide to get next page. It's just a way. So now it's page 2. It's just a way to execute some REST. Okay. First, HTTP, resources, reuse of HTTP verb. That's it, because you all know already about REST, right? So let's switch now to gRPC. gRPC has been created by Google, released in 2015. And it's RPC, remote process call. So let's go to the RPC one now. I will close that. So first things to do when you implement gRPC API, it's to provide the signature. This is a file, a proto file, where you will define all the method and all the objects you need to work with. So if you're old, like me, and you already did some SOAP, this is some kind of contract. But it's not as good, because as you can see, it's proto. So protobuf is a serialization format, binary format, to speed up communications. It will take the payload, compress, serialize as binary, to speed up the exchange, to be as fast as possible. Once I define my signatures and object, I got some Maven plugin, never mind, some plumber, that will generate from you stubs. So the endpoint exposing actually your gRPC function. And if I go to the class that has been generated in here, yeah, it's pretty small, but basically gRPC will generate a blocking service, an asynchronous service, and a reactive service, just to be able to implement any of the pattern, be very fast, consistency level 1, be very secure, consistency level quorum, or to be fully reactive and go nuts as fast as we can. So unfortunately, with gRPC, there is no API. So to test, and if you would like to test with the GitHub repo I will provide you, no, this is not what I need. I need the user ID. Go back here. And now I need to test with my user ID. Okay, so run as. Oh, what I got? Connection refused. Why? You didn't follow. I didn't start the application. It's better when you start. Okay, let's do it again. And now we get back our comment. So gRPC is very static. You need to provide a very static signatures object. And it's not that easy to test, as you can see. There is no UI, but it's probably the fastest, as we are using some binary serialization format. OK, last but not least, GraphQL. The latest, or I should say the latest in the Java world, because GraphQL has been created by Facebook in 2012, and it has been open and released in 2015. And now, if you are a JavaScript developer, you all know that they're going nuts with GraphQL. While if you want to do it with Java, let's see what it looks like. So like GraphQL, like gRPC actually, you need to provide the contract. You will define some schema, and in the schema there are queries, read-only access pattern, and mutation. And funny enough, it's exactly the same word as we are using in Apache Cassandra when we need to change the data. It's called the mutations. We define the object, input, output. OK. And we will create, no Java generation here, we will create object related to the object we created, and we will implement the query resolver and mutation resolver. Those two classes came from GraphQL Java, like we have here. and GraphQL servlet. You will see that in a minute. So I define my GraphQL contract. I create my Java object, and I implement the method with exactly the same name as I provided in my interface, and I will do my code. Now, if I need to test it, in GraphQL, there is a UI, GraphQL, that will help you a lot to do your testing. So don't forget to start the application, GraphQL. OK, and it's a web tool, so we should be able to see something like that. And if GraphQL, look at that. The main thing is discoverability. I got my schema. I can see all the queries available in the GraphQL endpoint, get video comment, get user comment, and I can navigate into each of the objects and go deep dive to see what is exposed by this API. So now if I want to do a query, well, I have a query here available for you, but I can maybe, what I need is, again, my user ID. Let's do it like that. OK. And then I execute. And I get back my comment. But nice things with GraphQL is you can tell exactly which result you want. So if I want now not only my comment, but also the user ID, is on the client side that I will just define exactly which field I need. That means that the response will contain only those fields, and you will get a lot of the payload volume by just providing the exact signature of what you need. OK, so enough with demo. Let's get back. Or not. OK, here we are. OK. You saw a sample application of REST, gRPC, and GraphQL, Java, how to implement it. But how do you choose among the three? OK. I say already some things, but if we are some technical architect, is there any technical architect in the room? Some very senior people? Those kind of people are very serious, technical architect. We need to figure it out, and we need to find all the criteria to analyze which implementation is the best. So for the MCD, we need cardinality, versioning, confidentiality, atomicity. For application queries, well, we can have filter, paging, sorting, throughput, latencies. Now we also know which technology we will use, which kind of database. That means we are aware of the latencies, if the database can do caching or not, if you can go async or not, and which kind of volume you can have. But what about the developers? I mean, people that will implement your API. What are the experience? How do they build? How do they test? Is it a code first? That means I will create my code, like for REST, or contract. I will first create my gRPC of GraphQL and then generate my code. What about packaging, documentation, and such? And not only that, but if now your consumer, your user, what is their experience as well? What is the profile? What kind of technology are they used to do? With all those criteria, pretty Avery Tower technical architect will just define, again, very serious analysis matrix. And maybe this is what you expect when you come at this thought. Please give me the decision tree with all those nice criteria, and boom, this is it. So on the top over here, everybody can see? No, just kidding. So this is not the way we are working, of course. We are not serious architect, we are developer, so we need some best practice. OK, so REST. If you can see with REST, the best part is decoupling client, decoupling server. Well, there is no contract, but at least if the server changes the signature, you are not stuck. You don't have to change, okay? You can do some versioning. Remember, in the URL, I provide you v1, and if tomorrow I need v2, I can make those two API live side by side. And as it's pretty old, mature, somebody told REST is a new soap now. So you got tons of tooling. And what I mean by tooling is mostly API management. I don't know if at your company you are using such kind of tool, but this is a proxy on top of your API that will do a lot of technical function for you, like monitoring, security, throttling, rating. And all these features are available for now only for REST endpoint. So if you want to expose API to like public API, provide an API portal like Google can do, for now it's all REST, at least for this kind of tool. But with REST, see the payload we got, it's pretty big. Even if we are using JSON, which is a small improvement already against XML, with XML you still have the schema, but it's pretty verbose, right? And there is no discoverability. You got the endpoint, but you don't really know what answer you will get, except you are using some pretty documentation tool I provide. You know the Swagger, the nice UI? It's generated documentation based on the code. Except from that, you don't know what's happening under the hood. And here I did a select. Give me all the command for a user, which is pretty a CRUD, and is really good for CRUD, okay? But now if I have to compute a price, I don't know if you try to do an API to compute a price, to execute a function, a command, well, it's all tweaks. You can do it using some post URL, strange things, but it's not the way REST HTTP verb has been created. So, this is now the first pictures you can take. 3 pictures today. This is the first. So, REST is still the CRUD superstar, to my understanding. Pretty easy using HTTP verb to do create, read, update, delete. It's relevant for mutation, that means change in real time. I want to update my data based on a table, on a schema. And it's relevant to public and web API. Why? Because the tooling and documentation is there and pretty easy to do. Okay, so what about gRPC? gRPC is not as well known as REST. It's a high performance framework. It has been created by Google, I already said that, and it leverages on HTTP2 framework, HTTP2 specification. So it's all about streaming data, multiplexing, WebSocketing. It's all about speed. Speed. Serialization, okay. And you know what? Actually, we chose gRPC in the end to implement the killervideo.com application. Why? Because we need to provide you the same API, not only in multiple ways, but in multiple languages. So Python, C#, Node, and Java. Well, by using gRPC, we just create a single proto file, and everybody can generate not only the client, but the server from the proto. It was easier for us. So the interoperability for multiple languages. No. But a proto file is pretty ugly and not very extensible. And so you are very stuck, like you were with SOAP. You are very stuck with your client and server. So you should use that only if there is no big modification in your contract. And protobuf, well, it's pretty basic. You cannot do a huge and nested object. It's just two levels of depth. So gRPC should be used and can be used for distributed network of service. If you have a lot of service doing a network and you need speed, nobody's waiting, and go do some API all asynchronous, you can switch to gRPC. And high throughput, and this is the reason why Google did it in the first place, to speed up communication between services. All about streaming. And on the contrary of REST, now it's all command-like, function-like, because you will define some method. Slack is using gRPC. And SOAP was a bit like that, RPC. This is what it means. Define your method, do some stuff. You can still do some CRUD, save my object, update my object, but it's artificially created method to do that. So best fit for command-like. So now, what about GraphQL? Well, the shiny part of GraphQL is the discoverability and GraphQL, obviously. I define my endpoint, I get this shiny, nice UI, and my client can now discover what I need. Super cool. Second is, I will ask exactly what I need and nothing else. That means I have a very small payload, or I get only what I need. And it's still matching standard. It's still HTTP over JSON. So that's pretty neat. But, for now, GraphQL is a single F point, /GraphQL. And all the call will go through this exact endpoint. No versioning. If you want to version, at least with the Java stack, you need to create 2 runtimes. What about monitoring? With the API management tool at the higher level, with the proxy, we can say each time I invoke this URL, I will get a ping in my monitoring system. Now with GraphQL, you cannot do that. The only way to implement some monitoring is doing in the code, at least to get fine-grained monitoring and do pay-per-use to your customer for the API call. So it's nice for customer. Oh, yes, it is. But it can be nasty for DB. That means, OK, I discover what I need. I get my user. And now I would like to have all the groups for this user. If you generate the GraphQL stub like that, by default, you have your user, a list of groups. It will do some n+1 select. That means it will request again the database for any single new record. And this is not what we want. In the GraphQL sample I show you, I just said, OK, no, I will create the method. I will tell you exactly what is granted and what is not. And so you have to be very careful when you implement GraphQL on top of database to avoid this API to query again and again and again the database just to get a simple result. At least for Java, I find that GraphQL is still complex. You need to provide the signature. You need to insert the plugin. Sometimes you cannot generate. Sometimes you can, depending on the database. It's still young. And so GraphQL is pretty nice, and maybe you're already told if you're using some JavaScript framework, but it's good for backend, for frontend. You have your frontend, JavaScript, Shiny, or your mobile app. We need to access data in the backend. Well, GraphQL is pretty neat here. Why? Because it can compose service. It can limit the number of data that will come from the backend to the frontend. And it's pretty easy to implement in JavaScript, and we know that front-end is all about JavaScript now. I'm still doing my front-end in TimeLeaf. I'm pretty sure you don't know what it is, but I'm still doing this old school way to implement services. So composing, service aggregations, everything when joins is needed. And in the previous talk, this is exactly what we got, yes. You got a proxy REST and the GraphQL to just aggregate the data. And I said last but not least, GraphQL is relevant when the volume matters. You have a mobile, not a good bandwidth. I will just ask exactly the field I need just to get my payload. OK. So now you got a pretty big picture of the three, at least our feedback about the three ways to implement the GraphQL. And here you got some links you can take. So the first one is all about the source code I show you. The second one is video and training we are providing on YouTube every week. Third is Twitch, because we are young. We are doing some live coding on Twitch every week. And the last but not least is the DataStax links, where you provide all these training, getting started, code, and demo. Thank you.